Good morning, Integrated 3 classes. Good afternoon. Uh, Tomorrow you will be taking the free response test. This is the test you took yesterday, the multiple choice. So I'm just going to go through these problems and make sure I clarify. I'm not passing out your tests because they still need to be graded, but we're going to go over the items. Okay, and you just sort of have to remember if you got one right or wrong to prepare for tomorrow. I will be out all week. I had appendicitis, which means they had to do surgery and take out my appendix. So um, I'm gonna have to be out for the whole week. I'll probably be back next Monday. Let's go ahead and get through this. So this is one of the questions you had on the test. It says which graph could represent the function negative x cubed minus x squared plus 5x. So you know you're looking for a cubic, and we have all these are going to be in that cubic form. So you could have graphed this and seen it, but there is a way to do it without it. Which is here on this one you have the negative in front of the x cubed, which means its end behavior is going to be going down, so it can't be this one and it cannot be this one. Okay, neither of those are going to work. All right, and then from there we just need to compare these. Okay, so how do I know which one it is? Well, I would like y'all to graph it, but what I can do is I can actually change the form of this. So it'd be, I'm going to factor out a negative x, which is going to give me x squared plus x plus 5. Okay, and we're going to try to factor this. So we're trying to take the factors of 5, which is 1 and 5, and that's it, to add to get here. Well, uh, there's no combination that's going to add to get this x, or this 1 right here. So we know that we can't find exact factors for this, but we do know one of them is 0, and the other one, well, if I do quadratic formula, I can figure out what this is. But let's just go ahead and graph it. That just makes it so much easier for us. Let me go to Desmos. And we are going to type in negative x cubed minus x squared plus 5x. So negative x cubed minus x squared plus 5x. All right, so now we can see, now we can see what's going on in the graph here. Okay, that's what it looks like. Match that up to what we have. This is the answer. Should have been A there. Okay. All right, next, analyze the functions. We have two functions here. It asks which has a greater degree. Well, the degree of this one, highest power is 3, so this one has a degree 3. By the way, I'm using a mouse, so my handwriting is going to be way worse than usual. So this one has a degree of 3. And then on this side with the table, so we talked about finding the degree from a table, you have to find the differences. So from here to here is minus 6. From here to here is minus 2. Here to here is plus 2. And then from here to here is plus 6. So it's not constant, so we got to do another one. So how do I get from negative 6 to negative 2? Well, I add 4. Negative 2 to positive 2 is also plus 4. And we have another plus 4. So that means that we have found our constant row of differences. That only took us 2 times to get. Okay. So that means that this one is a degree of 2. Okay. This one's a degree of 3, so we're going to say P of x has a larger degree. So we need to find that. Okay. P of x is a greater degree because R of x is a quadratic. That is true. When this has a 2, that means that it is a quadratic. Okay. So our best choice is that one. Okay. All right, next question. Here we're talking about transformations. We practice this quite a bit in class. We want to reflect the function about the x-axis. So that means there's going to be a negative in front of it, and translate it 3 units to the left. So the left means you're adding inside of the parentheses to produce g of x. Which equation represents that? Well, we know it's when we're saying to the left, it has to be inside of parentheses, so we have to get rid of that. These two. This will do a vertical shift. Now, all of these have negatives, so the reflection part, it's going to be one of these. Now we just also need to decide when it says left. Well, that means you're going to be adding, so D is the best choice for this one. On to the next, number 4. We graph the function f of x equals negative x cubed plus 24x squared minus 179x plus 459 is shown. It says determine the average rate of change between x is 2 and x is 5. So here's 2, go all the way up, get right here. And so I would say that that point is 2. It's about in the center. It's going up by 50, so this would be 225. Okay. Then it wants to know, go to 5. So here's 5, go up to here. There's that point. So I believe this is 5 to, that looks like 1, no, 75, yeah. So to find this average rate of change, remember we have to do the rise over run. And so we're going to take our second digit here, the 75. What did it take? How did I go from here to here? Okay, from 225 to 75. Well, what we're going to look at, we know we subtracted, so we can actually use our calculators to do this. We need, let's say, 225 take away 75. Well, we took away 150, so that means up here, though, we represent that as a negative. Remember to show what exactly happened. So minus 250 up top, and then how did I go from 2 to 5? Well, from 2 to 5, we added 3. Okay, so that should give us the right answer here. Let's see, negative 250. Well, I know it's negative, so we'll just do 250 divided by 3. And we get a decimal. So perhaps this is 5. That seems right. Let's see. Let me come back to this one in a second. Let's continue. So which type of polynomial could a graph with the given shape represent? So we see how many curves it has. It goes one, or how many points? 1, 2, 3, 4 maximum minimums. So that means that the degree is 1 more than that. So that would be a 5th degree polynomial that could represent it. Okay. All right, another translation question for number 6. The equation for f of x is given. The equation for transform function in g of x in terms of f of x is also given. Describe the transformations performed on f of x. So here's our equation. Well, first off, we see this 4, and we remember that that makes it more narrow when we do that. And then the minus sign means it shifts to the right that many units. So the best choice on this one would be B. Okay. If you put D on here, we did talk about that word stretch, a vertical stretch. I would also count that. Okay. Next says consider the graph. As we're looking at this, you'll notice that both sides are going down. You have 3 maximums and minimums. So remember that means that the power is 1 more than that. Also, since these are going down, both on the same side, that means it can't be an odd degree. So it can't be this one, cannot be this one. Okay. And then we're looking here at these two options, an even degree function with 2 relative extrema. Remember, extrema are your maximum minimums. Well, we know that we have 1, 2, 3 of them, so has to be D because it says there's 3. Next, we have what is the end behavior of this function? Well, you can graph this and you'll see it. I'm going to graph it here in a second on Desmos. Let me just get rid of that for a second. But how you could do this without graphing it? Well, you know the highest power is 5, so the directions that they're going, if I were drawing this, one of them is going down, the other one is going up, okay? Since it's positive, we know that the right side's going up and the left side's going down, okay? And so let's look at our options. As x approaches infinity, so well, I'll write over here. As x goes to infinity, so that means this right side over here is infinity. F of x approaches negative infinity. Well, that's not true because we said it is going up. So we're going to get rid of that. Look at this other one. X approaches infinity. F of x approaches negative infinity. Nope. We just said that's sort of the same thing. So here we go. As x approaches infinity, f of x approaches infinity. That's true. So that part's good. So f of x approaches, well, I ran out of space, positive infinity. Okay. Now we're looking at it going the other direction because b seems good so far. As f of x goes to infinity, f of x, well, we know that it should be going to negative infinity, so that's what we're looking for. Let's see if this question has it in there. So, okay, so this is it. As x, so we got as x approaches infinity, f of x approaches infinity, so that's right, on the right side. Then as x approaches negative infinity, so let me put, I actually need to put a negative in here as well. A little bit trickier with the mouse trying to do all this. As f of x approaches negative infinity, or as x approaches negative infinity, f of x is also approaching a negative infinity. So that is correct right there. We didn't even look at D, but I don't think we need to. Wait, they look like they're the exact same answer. Hold on. B is the right answer as it confirms everything here. So we're not going to pick D. Okay, which is the possible number of extrema for a fifth degree polynomial? Remember, extrema are the max and mins. And since it's fifth degree, that means there should be at most 4 maximum minimums. So we're going to say 4 right there. Next, the function c of x models the number of cookies sold each day by the bakery during a 10-day period. Between which days did the number of cookies sold by the bakery increase? So we're looking for going up, so do your intervals of increase. So let's look between 2 and 3. So here's 2, here's 3. And as you can see, that is definitely going down. So it's not that one. Let's see, C between 5 and 6 days. So here's 5, here's 6. Definitely not between those. It's still going down. 3 and 4. So here's 3, here's 4, going down between those. And then 6 and 7. So here's 6. Up, here we go. As it goes from 6 to 7, it is starting to increase. Okay. So we are going to circle that one. All right. 2 more questions to look at, and we'll go back and figure out that rate of change one. All right. Analyze the function. So here, if I multiplied all this, this one would have a degree of 2 because there's 2 x's in it being multiplied. Quadratic with a greater than 0, so it's not opening down. We know that this means it's opening up for this one. And it says exactly 1 real 0, so that means it has to just touch right there if we drew this on an axis. So this has a multiplicity of 2 in it if it's only exactly one solution. We have a picture of this one, and then our graph. We might as well go ahead and do the subtraction just to figure out what we need with this one. So this is take away 11 or 9, take away 5, take away 1, and then plus 3. We got to go again. So this is going to be, oops. Oh man. Let's start over, sorry. Minus 9, minus 5, minus 1, and then plus 3. So this right here will be plus 4, plus 4, and plus 4. There we go. So we know this is a quadratic, just like this one. Okay. Now we got to read through these options, and here's a big thing. Maybe you missed it yesterday, but you select all that apply. All right. So we have to be aware of those on multiple choice tests. Sometimes they'll throw those in, or we'll throw those in. Okay, so each function increases to infinity as x approaches infinity. Well, that would be true for this one because there's a positive 4. We can see it on this one. This one's true. On this graph here, it seems as the x's are going up over here, that it's going to be going up to infinity as we continue with these x's because it's going down, 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 and then starts going back up again. So this is positive. So actually, this is a true statement, but we got to select all that apply. The function s of x has the greatest y-intercept. Here's s of x. This last digit is actually the y-intercept, which is 6, which is greater than this one, which is right here, negative 40. The y-intercept on this one is this one here, 1. So far so good. And then the quadratic function t of x, so whatever this right here, it's opening up, and it says it has exactly one real 0. Well, with that, it's kind of, we don't know where it's going to cross the y-axis, okay? So we can't really make that statement to say that b is true because we don't really know anything else about this one. All right, let's look at the next one. The function h of x has the least y-intercept. Well, here's h of x. Negative 40, yes, that is true. It does. And then d, only v of x, right here, has a pair of imaginary roots. Well, it's a quadratic, so you'll notice that here is a root of it, 0, 1. No, excuse me, right here, 1, 0, okay? Then it goes back up. And we probably can't see the other real 0, but this is real zeros, and it's not going to have a pair of imaginary roots. So this one's not true either. So A and C are the best choices for this. Let's look at number 12. Which graph could represent a polynomial function with three real distinct zeros and a real 0 with multiplicity of 2? So remember, with the multiplicity of 2, that means we're looking for it to just touch the graph. So this one touches the graph right here. This one touches the graph. This one touches the graph. And this one touches twice. Okay. So we know it can't be C because it says it's not saying multiple real zeros with multiplicity. So it can't be C. Okay. Can't be C. So let's look at some of the other options. It says it needs polynomial function that has three real distinct zeros. Okay. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So all the rest of these have that. So it says select all that apply as well. So that's going to mean this, that we have a multiplicity here, and it has three distinct real zeros. 1, 2, 3. So this one's good. Then we look at this one. Here's the multiplicity, and we have 1, 2, 3 zeros. So B is also true. Then we look at this last one, three distinct real zeros. So here's the multiplicity. 1, 2, 3. Yes. So the only one that didn't work was this one. Let me go to, here's the key. So I was having an issue with this one here, number 4. So 4 is saying that it should be A. So let's look at A, negative 50, average rate of change. So should it be, so this should be a 5 on the bottom, but that's not what's happening. Or this should be a 150. Oh, that it is 150. I wrote it wrong. I'm sure some of y'all caught that. So 225 minus 75. Hold on. 225 minus 75. 150. I wrote it wrong. So minus 150. Okay. Well, good. I thought I was going crazy. So we divide those and we get negative 50. All right. Cool. Okay. That concludes this review of questions that you may or may not have gotten right or wrong on our test yesterday. Tomorrow, be prepared to take the free response portion. Right now, what I'd like everybody to do is grab out that worksheet that I gave I gave it out Friday. That is going to be due, and you can practice a little bit more with these with these problems. And any other homework assignments that you need to get done, you go ahead and start getting those finished and turned into the box. Good luck tomorrow. You will be testing again. And then I'm probably going to do a video lesson for the rest of the week that will be shown to you guys. Okay, so make sure that when that's happening, you're taking notes. And when I give practice sheet, you'll be practicing. Okay.